Hello everyone, it's been very long time and very happy to see you all with our new video on NTSE previous year questions. In this video, we are going to solve the NTSE previous question with step-by-step approach. Come, let's get into the video. The very first question is the size of colloidal particles are. So, colloidal particle size ranges from 1 nanometer to 1000 nanometer. Actually, the colloidal particles will be intermediate particle size than that of true solutions and suspensions. For true solutions, it will be less than 1 nanometer, whereas for suspension, it is going to be more than 1000 nanometer. So, colloidal particles will be lying in this particular range. So we can conclude the particle size as 1 nanometer. That means 10 power minus 9 meter to 1000 can be written as 10 power 3, and nanometer can be expressed something like this, which means 10 power minus 6. So the size of the colloidal particles are going to range from 10 power minus 6 and 10 power minus 9 meter. The correct option that it matches here is option B. Here, we are not only solving this particular question, also we are trying to cover in case other than this colloidal particles, what may be the other questions that can be framed based on the same pattern. So note down all those questions for your future references. This is true solutions. I said a true solutions particle size will be less than 1 nanometer, whereas suspension will be greater than 1000 nanometer, and the colloidals particle size will be in between true solutions and suspensions. So colloidal is coming in the mid range. So it's quite easy for us to remember. So that's the trick for this and tip for this particular question. Let's go for the next question. Synthetic fiber nylon is whether polyamide, polysaccharide, polyester or polyethylene. That's the question to you. Basically, you must have an idea about what is nylon is all about. So nylon is basically a condensation polymer. What is a polymer? Poly stands for actually a many, mer stands for parts. So poly means many, mer stands for parts. So many parts are going to join together and it's going to form nylon. So let us see one such example of nylon preparation, nylon 66. So this nylon 66 is prepared using adipic acid. Adipic acid can be represented as CH2 4 times, this is what we call a scud bond, COOH. Since it is an acid, carboxylic acid COOH functional group will be present. And this is going to in turn react with hexamethylene diamine. Methylene means CH2 group with two valencies on the both sides. Methylene group that is going to be present 6 times. Hexamethylene diamine. So amine in the sense NH2. There are two amines, so this is called as hexamethylene diamine. So we call this as an adipic acid, and this is hexamethylene diamine. So when these two reacts, this is going to condense, as I said, condensation polymer, which means removal of small molecules may happen, such as water, ammonia. When those things are happening in a chemical reactions, we refer that reactions as condensation reactions. Here, we are going to remove water molecules. You can see here, OH from this particular compound, and same way OH from here, one H from here will be removed. So that will be removed as a water molecule. Same way here, H will be removed, and this H will be in turn reacting with the another molecule of adipic acid. So this reaction continues to happen, and we will get the product as something like this. Since this OH has gone, I'll start with this bond, C double bond O, and then CH2 4 times C double bond O, and this is now in turn connected with one hydrogen and night hydrogen, NH. Then CH2 6 times, which is hexamethylene, and then NH. This continues to grow. So this continues to grow. And we will represent something like this, N times. So if you see here, OH and H, one water molecule is removed. So this is what we call it as nylon 6,6. Why do we call this as nylon 6,6? Is basically, you can see here 4 carbon, and here 1 carbon, and here 1 carbon. So totally there are 6 carbons, and same way here also there are 6 carbons. Since at both the sides there are 6 carbons, we will say this as nylon 6,6. So what that 6,6 represents is the number of carbon atoms in the polymer chain. Now, since it is a condensation polymer, we receive here the water molecules are getting eliminated. So what is polyamide? We know the amide functional group is something CONH2 functional group. So this is an amide functional group, CONH2, and when we try to write it as a bifunctional group, we will write something like this. So when a compound has CONH compound, so something like this, CO and then NH, then we call that as an amide. So this polymer is therefore categorized under polyamide. So synthetic fiber nylon can be said as polyamide. Then there are some other options that we must be in a position to understand. Let's little talk about and little understand what is polysaccharide, polyester and polyethene is. So polysaccharide, saccharide means sugar, which has come from the word saccharin. Saccharin means sugar. Basically these are carbohydrates. So polycarbohydrates, or we can say polysugar molecules. So like for example cellulose, starch, all these comes under the category of polysaccharide. Cellulose in turn comprises of two components. One is amylose and the other one is amylopectin. In all these, glucose molecules will be present. Glucose is basically a sugar, so that's a carbohydrate. So if at all they ask the question in another format that cellulose is a dash, then you'll say it's a polysaccharide. Same way, let's see what is polyester. We know the ester functional group. What is that ester functional group? Is COO. It's a bifunctional group. I'm writing it as a bifunctional group. Actually, we will generally represent it as RCOOR, where R is the alkyl group. So this is what is called as ester functional group. When this particular group, like here we have seen CONH. Instead of CONH, if we see COO group, then it is called as polyester. So we will see one example for polyester. And the polyesters like terylene or dacron can be one such example that you can consider. It is called as terylene or dacron. And let's see how the terylene or dacron is prepared. Terylene is prepared using ethylene glycol. Ethylene glycol is a dihydric alcohol, CH2OH, CH2OH. Then this ethylene glycol is made to react with terephthalic acid, COOH. On the opposite side, you write one more COOH functional group. So this is going to give you the terylene or dacron, which is an example for polyester. So this is ethylene glycol and this is terephthalic acid. Now how we are going to write here is something the same pattern which we followed over here in the previous pattern. Here we are going to remove only hydrogen. If we remove hydrogen, let us remove here OH. This is also a condensation polymer. Since OH is removed, we will remove hydrogen from here. Since hydrogen is removed from here, on the other end, to remove OH, which means it should be like a removal of water molecules. That's what is done finally. So I'm trying to write the final product based on this. So how do I write this? This is a bond, which is an extension bond O, CH2, and then CH2. That is in turn connected to oxygen, C double bond O. Then you will see a benzene ring and C double bond. Now this is what one unit, and since it is a eliminating water molecule, we will call this itself a condensation polymer. This is also a condensation polymer. I hope you can get it. The condensation polymer here is because it removes a small water molecules. Here you will see it is releasing C double bond O. O. So this is a functional group. This functional group is what we call it as a ester functional group, and this is going to get repetitive manner it is going to come. So that therefore it is called as polyester. So that's what you can see the previous one. What is polyester? And next is given as polyethene. So what is polyethene? Polyethene is something which is going to produce from ethene. So ethene can be represented as CH2 double bond CH2, and here there will not be any elimination. Instead, many molecules are going to get added. It will be added something like this. In the sense, it is called as homolytic cleavage. The bond which I have represented here is called as homolytic cleavage. This homolytic cleavage will result in formation of the free radical, which you will be learning in the higher courses, possibly maybe when you go for higher grades such as 11th and 12th standard. Now let us see here how this is getting attached. This will create a single bond. All the double bonds will become single bonds now. So this unit is getting repeated. So this is what we call it as N. So this is one time. Since I have taken two times here, you can see CH2 is coming two times. When I take N times, then this is going to come N times. So therefore we will say this is a polyethene. Here you will see there is no molecule such as water is eliminated. So this polyethene is an example of addition polymer. It is not a condensation polymer. So this is another question that may be raised. So polyethene comes under addition polymer, whereas terylene or dacron, which is a polyester, and nylon 6,6, which is a polyamide, all these comes under a condensation polymer. And polysaccharides, this polysaccharides will have a glycosidic linkage that you may learn again in higher courses. Let's move on to the next question. Main component of LPG. Liquid petroleum gas is what is shortly called as LPG, and this LPG is generally obtained from the natural gas, as we all aware. And this is basically, you can remember methane, ethane, propane, butane. So based on the hydrocarbons, we can say it is propane and butane. Like 1 carbon, 2 carbon, 3 carbon, and then 4 carbon. 1 carbon hydrocarbon is said as methane, 2 carbon is said as ethane, this is called as propane, and this is called as butane. So remember 3, 4 for LPG. So generally we will remember this by saying 3, 4. 3, 4 is just to make you remember that 3 carbon, 4 carbon content. So propane and butane is the correct answer for the LPGs. Now next fourth question is cinnabar is an ore of which of the following? So ore is an important one from where the metal is generally getting extracted. So cinnabar is called as HGS. It is a sulfide ore of mercury. So we call this as cinnabar. So HGS, which means it's Hg will be the answer. We also have magnesium, but magnesium will not have a sulfide. Instead, it will be existing in the format of carbide. That is called as magnesium carbide. We will call that as magnesite. And Ag and Au are generally non-reactive, which non-reactive in the sense it will not be existing in a form of oxides or sulfides. Generally it doesn't exist in the form of combined one, but silver sometimes, very rarely, exists in a form of sulfides as Ag2S. So it will exhibit as sulfide, so that we call it as a silver glance. So I want you to remember all these three: silver glance, magnesite, cinnabar. And Au, this is basically native. This is native in nature. When I say native in nature, that means it is going to exist in uncombined form. Why it is existing in the uncombined form is because of its non-reactive nature. Gold is basically non-reactive. It shows very less reactive nature. So therefore it will not have chances to combine with any other substances, and it will in turn will not exhibit in any other state. So cinnabar is an ore of mercury. My bad. Question 5. The general formula of alkane. Now just we have seen the alkane can be represented as methane. The next series can be represented as methane, ethane, and then propane. 3 carbon content is propane. Keep increasing 1,1 CH2 in between 2 CH3 groups at the terminal. So you will see here 1 carbon, 4 hydrogen. So the number of carbons is considered to be N as 1. So here there are 2 carbons. In short, I can write it as 6 hydrogens. Here N as 2. Here 3 carbons, 3 plus 3 plus 2. It's going to be 8 hydrogens, where the N equals to 3. N represents the number of carbon. And then 1, 2, 3, 4 carbons here. 6, 8 plus 2, 10. So N equals to 4. So it looks like, if you see here, the trend that it follows here is Cn H2n plus 2. If n is equals to 4, then this is going to be 2 into 4 plus 2, which is going to be 10. So C4H10 is basically comes under the formula CnH2n. So remember, alkane is CnH2n. So the correct option for this is second option. So same way, we'll have to also learn about alkenes. Alkenes is CnH2n. So remember, plus, 0, and then minus. So that's the trick that you want to be remembered for this type of questions in future. Minus 2, whereas for alkane it is plus 2. So plus 2, 0, and here minus 2. So alkane, alkene, and then alkyne general formulas can be easily remembered. Question 6. What is going to be formed when chlorine gas is passed through the dry slaked lime? We know the slaked lime is calcium hydroxide. This is generally formed when quicklime is mixed. Quicklime is calcium oxide, right? So the calcium oxide, when it is treated with water, then it will form calcium hydroxide. This calcium hydroxide will be in a form of suspension. If we filter it, we will get a dry slaked lime. So the aqueous solution is called as lime water, and this calcium hydroxide is what we call it as a slaked lime in a dry form. When this calcium hydroxide is treated with chlorine, it forms a bleaching powder, that is calcium oxychloride. We call it as calcium oxychloride. It will liberate water molecules. So the correct product for this is 3, calcium oxychloride. I would also like to add another point for this. This calcium oxychloride can also be represented something like this, where the cation is calcium 2 plus, the anion can be represented as ClO minus and then Cl minus. So this is what we call it as calcium oxychloride. So next, which of the following is a strong base? First option given is ammonium hydroxide. Sometimes this ammonium hydroxide can be given as aqueous ammonia. Ammonia gas when it is dissolved in water, or ammonia liquid when it is dissolved in water, then we call it as an aqueous ammonia. So both are one and the same. So basic one that you must know about ammonium hydroxide is this is very weakly basic, very weakly basic. So they are asking for a strong base. So ammonium hydroxide cannot be a strong base. And next, calcium hydroxide. Yes, it is one of the very strong base which will dissociate into calcium 2 plus 2OH minus. Same way, potassium hydroxide will be dissociating into K plus OH minus. So here, if you compare these two, one hydroxide is formed from alkali metal, the other one is from alkaline earth metal. This is from alkali metal hydroxide. The other one is alkaline earth metal hydroxide. This is alkaline metal hydroxide. So comparative to alkali metal and alkaline earth metal hydroxide, we say alkali metal hydroxide are more basic. Why? Because it's losing electrons is quite easier. It has to be seen in the terms of which cations can be easily produced rather than seeing OH minus. It's not the number of OH minus that decides the basic nature here. It just decided by the cation formation. When comparative to K plus and Ca2 plus, K plus forms readily. How the K plus forms readily? Because potassium has to lose one electron. Then only it will become K plus. So this is quite easier, and that will require only less energy when comparative to calcium. Calcium, if at all, has to convert into calcium 2 plus. First it has to lose one electron, and then further it has to lose one more electron, which will require slightly higher energy than the potassium. So this will require a lower energy. We call that as ionization energy, because it is ionizing finally into a cation. So therefore we will say this requires lower ionization energy than calcium. Since it requires lower ionization energy than calcium, this quickly occurs. So thereby, when comparative to alkali metal hydroxide, alkaline earth metal hydroxide are less basic. So alkali metals, so this should be that. When it comes to sodium bicarbonate, the sodium bicarbonate is basically, it's an acidic salt. And this forms basic solution. And that basic solution is slightly weak in nature. So therefore, we will consider 4 as the best answer for this. Question number 8. You will see there is a reaction given. Based on the reaction, they have asked what is the type of the reaction. You can see here sodium chloride. Observe the reaction quite carefully, and you will see at the end of the product. What has happened is, instead of Cl, now NO3 is there. Instead of AgNO3, here Cl is present. So which means you will see the Cl and NO3 is got displaced. So there is a double displacement. So this type of reaction is called as double displacement reactions. An alloy which does not contain copper. So we must know various alloys and its compositions to answer this. There may be slight tips and tricks that you can remember in this question as well. So magnaluminium, they have given you a very first option as magnaluminium. So the word itself says magnesium, Al stands for aluminium. So this is an alloy of magnesium and aluminium. So the magnesium content will be around 5%, aluminum content will be around 95%. Then bronze and brass. Many of you get confused between bronze and brass. That can be very easily remembered. Brass is something like 29 and 30. Remember, whenever the brass is asked, remember 29 and 30. What is this 29 and 30? This is actually an atomic number. So copper is atomic number 29 and zinc atomic number is 30. If you want to go for one more step, remember 28, 29 and 30. That is going to be our German silver. So it's quite easy for us to remember the alloys in future. So 28, 29 and 30. Can you guess what may be the element symbol for 28? Yes, your predictions may be right. I'm going to write it here. Just check. That's going to be nickel, copper and zinc. So this is what is called a German silver. Now bronze is going to have a tin apart from copper, Cu and Sn. So it's quite easy for you to remember. Remember this always, it is going to help you a lot. 29, 30 for brass. So when it ends with yes, you know the answer. Say yes, you know it. So say 29 and 30. And German silver, the alloy compositions 28, 29 and 30. So it is very easy for you to remember. And the term magnaluminium itself will says that magnesium and aluminum is contains, that the maximum metal that it contains is aluminum. That itself may be sometimes questions. Magnaluminium contains maximum amount, whether magnesium or alloy or aluminum or some other metal may also be given. So you can answer aluminum. Which of the following is not an allotropic form of carbon? What is allotropes basically? Allotropes is various forms of an element. Various forms of an element or various crystal forms of an element are what we call it as allotropes in short. So diamond, graphite, fluorine, all these are the allotropic form of carbon. Since all these are allotropic form of the carbon, it is none of this is the answer for this question. A substance which oxidizes itself and reduces others are called. So remember, you will be notified always by your service to the society. Same way here, if a particular substance is oxidizing itself, that will not be recognized. Only it it does something to the other substances, that is reducing. So that means it is going to be a reducing agent. So remember, oxidizing agent is oxidizes other substances. When it is oxidizing other substances, themselves, that particular substance will undergo reduction. Same way, reducing agent reduces other substances. So when reducing the other substances, themselves will undergo oxidation. So it's quite easier, right? An oxidizing agent is also called as oxidant. Reducing agent is also called as reductant. And dehydrating agent, the one which removes water molecules, that substance is called as dehydrating agent. We can consider sulfuric acid itself is a very good dehydrating agent. Potassium bisulfate is a very good dehydrating agent. Alum is a very good dehydrating agent. Catalyst generally increases the rate of a chemical reaction if any chemical reaction is very slow, and if at all we have to increase the speed, we will use that particular substance. So the answer for this is thereby reducing agent, since it reduces other substances. Next, question number 12. Water of crystallization in gypsum and plaster of Paris. So gypsum and plaster of Paris both are the compounds of calcium. Gypsum is one of the important components in the cement that contains two water of crystallization. POP we shortly call the plaster of Paris as, and that contains half water molecules. So the water of crystallization that it has here is 2 and 1 by 2. So look at the order what they have asked for. First order is gypsum, then POP. So which means first say 2 and then 1 by 2. So the answer over here is 2 for this question. Question number 13. Which of the following sets doesn't belong to a group? So we know lithium, sodium, potassium are existing in the periodic table in group 1. We call that as an alkali metal. Same way, beryllium, magnesium, calcium, strontium, barium, all these are alkaline earth metals. I'll represent it as AEM. And same way, helium, neon, argon, all these are at group 18, we call it as inert gas or rare gas. But nitrogen, oxygen, fluorine are existing in a row. So it is no more called as a group. So the one which doesn't belong to a group is nitrogen, oxygen, and fluorine. So basically you must have a rough idea of the positions of elements in the periodic table to answer this question. So ensure you are exposing yourself to the periodic table. Next, a byproduct of soap industry. So soap industry uses oil or fats to produce the reactions. We'll see the reaction. Triester or triglyceride, which is oil or fat, is made to react with sodium hydroxide and it forms soap. Since C17H35, we call this as a sodium stearate. Here the soap molecule used is sodium stearate, and that in turn gives the byproduct as glycerol. Because our major product in this concern is soap, and this is the byproduct, which is glycerol. Remember differentiating between glycol and glycerol. Glycol is basically a dihydric alcohol. We have seen dihydric alcohol in nylon preparation, ethylene glycol. So CH2OH is ethylene glycol, where it has 2 OH, whereas here it will have 3 OH. So this is also called as trihydric alcohol. Glycerol is also called as trihydric alcohol, whereas glycol is referred as dihydric alcohol. So based on this, the byproduct of the soap can be said as glycerol for this. Let's go for the next question. Corrosion of copper gives rise a green coating on it, which is they're asking the formula for the green coating. Generally, the copper, when exposed to the moist air, it forms carbonate and hydroxides. So the reaction can be represented as something like this. When the raw copper is treated with moist air, it contains water, carbon dioxide, and then oxygen. So this is what we call it as moist air. So this will in turn convert into carbonate and hydroxide. So this is the responsible for the green coating. Generally, green coating will be formed, whereas for iron there will be a brown coating. We will call it as a rust. For iron, we'll say Fe2O3.XH2O. We call this as a rust, and here we call it a green coating. The rust will have a brown coating and copper will have a green coating, something like this. So thus the answer might be for this is fourth option, copper carbonate and copper hydroxide. I hope all the It's tricks wherever it's highlighted in the every question and the detailed analysis you might have got it. Let's go through again and analyze each and every questions and practice more and more questions. And in case if you get any doubt, please comment in the group in the same channel. We will get back to you on the same channel. Thanks for watching. Subscribe to the channel.